Hello and welcome to this second video about the procedural sky generation. My name is Stefan Persson. I'm also called Infantia, and well, online I am anyway, not in real life. It's just the name I go by when I create content, game assets and games and sound effects and music and all that stuff. So let's move on. If you didn't watch part one of this, I suggest that you watch that one first, because it basically goes through how this gradient sky was created and how we're going to be using it. And in this video we're going to reuse some of the code, and instead of having just a separate game object like this and that's in the scene, we want to create a game object that is hidden and attached to the camera at all times. So basically all you get is the gradient, but it's always fixed to move with the camera as if it was a child of the camera, but without being a child of it. And it'll also ensure that it's always spanning the size of the viewport, regardless of what proportions that you have. So if you didn't watch video one, I highly suggest that you do that. And if you did, let's continue with splitting this code up and reusing some of it to create the fixed camera sky as well. So the first thing we're going to do is we've only created one script here called gradient sky. And we want to first of all rename this one to camera sky common, because we're going to be reusing some of the code. In fact, actually, let's keep it like that and let's rename it to, so I press F2 here. This is really nifty that you can rename stuff in the editor. Let's call it gradient sky object, and then we need to rename this script file as well, otherwise it'll flip out. It needs to always have the same name. So that's to signify that this version of the gradient sky is the one that creates a separate object in a scene to be used as any other game object. So the thing we want to do now is we want to create a second script called gradient sky common. And let's clear this one out. And then let's open the object as well. We can close this shader. We don't need that one anymore at the moment. So we have the common script here, which is empty, and inherits from mono behavior. And in here now, we want to change the gradient sky object to inherit from gradient sky common instead, because we're going to move some of the code into the common code, so we don't have to rewrite the same stuff all the time. Because we're going to be wanting to create a procedural mesh and a default gradient also for the camera fixed one, and rather than having to write all the codes twice, let's just inherit from this one instead. So what we want to do is we want to move some of these methods. We want to move the create mesh method. Create default gradient is also going to be reused between the two. Create mesh renderer, and even checking if a color key is approximately equal. We want to be able to reuse all of this. So let's cut that out, Control X, and paste it into this one instead. And as you can see now, a gradient, everything that's underlined red here is because it's not defined in this parent class. So we need to move this one as well. And the cache gradient, I think we're going to need as well. Let's have a look. So that went, the red lines went away to indicate that, okay, I do have access to this gradient now, but we have cache gradient, which we also need to move. So let's move this code. Control X. And let's paste it here. And those red squiggly lines went away as well, because now it does have access to these here. What we do have is some red squiggly lines here, and that's to say that it's inaccessible due to its protection level. This one is by default, since we haven't said anything here. These are private to this class only, to the common class. And what we need to do to make it shareable still as a private, not publicly available, but we want the children or the classes that inherit from this one, we wanted them to be able to access it. And by writing protected here, then we can access those. So with the protected, let's see here, protected. Now we can access those from here as well. No errors there anymore. What I like to do sometimes as well is I want to, if you want the option for some inherited class to be able to overwrite those, to have their own procedural mesh, maybe you wanted a little tweak for something in one subclass, then you can do as well. You put virtual there. And that means that I can create a method in here if I want, but I need to override it. And then I can create a mesh here and return that one if I wanted to act different in this one. But since we don't want to override and we don't want to do anything like that, we should be all right by keeping these without virtual and just keep them protected so they can be accessed in the child classes here. So let's give this a go first of all to see we haven't broken anything, and if we have, let's fix it. Let's clear all the objects here, remove the components. To start by this one. And then now we need to add, we don't want to add the common because that won't do anything. The reset, everything that calls this here to create the shared mesh to begin with, and the mesh renderer, that's located still in this child class. So let's do add the gradient sky object. And there we go. There's the sky, even though it's a small one. We can rescale it. And yeah, so we haven't broken anything, which is good. But what we did do was move the procedural mesh generation, the gradient definition, and the mesh render creation, and the color comparison. We moved that one to this reusable parent class. So the second thing we want to do now is create one that's called gradient sky camera, because this is one that we want to attach to the camera rather than a separate game object like this. And to save some time, let's copy the content of a lot of, or some rather, should I say, is somewhat similar, but not exactly. So let's copy some of this, or in fact, let's not, let's just write it from the beginning anyway. First of all, we want to execute this one in edit mode like the other one, so we can detect if the gradient has changed. And then we want to have the ability now to put this gradient sky, we want to put that at the camera instead, right here by the near clipping pane, or by the far clipping pane over there. And we want to resize it and rescale it to ensure that it's always exactly this size. So when you define a gradient, you're going to know that the color that you set at the top is always going to be at the exact top, and the bottom one is going to be always at the exact bottom. So what we want to do is create an enum here called clipping pane. And let's give the option to set it to either near or far clipping pane. And then we need a variable to keep track of what is actually selected. And it's of the type clipping pane. Let's call it place at clipping plane. And let's default it to the near one, which is going to be, basically it's not going to be visible in the scene, then the gradient is just going to appear as a little small thing in front here. And we're going to set the rendering queue so it actually renders last. So normally when you watch a scene, you won't have the sky to worry about. You won't accidentally select it like this one, for example. It'll just be a really tiny screen here in front that you'd only see if you zoom in like this and select the camera. So once we've done that, we also want to start using a child object now, rather than, we don't want to assign a mesh to the camera itself. I don't think that would be too pretty. So let's create a hidden child object of the camera. And by doing that, we want to do a private game object called child object. And let's hide this one. We don't actually need to hide it. So a private game object called game object. No, we want to call it child object. And then I'm going to start defining some variables to be used for the camera. So we want to have a reference to the camera component. And then, as we did the other one when we cached some of the values for the color keys, we want to cache some values for the camera. Continue here just with the float for the field of view. And then an integer for the camera width. We want to cache the height as well. And finally, we want to do a cache of the clipping plane as well. Let's rename that one properly. F2 is a nice feature. You can rename and it replaces in all the project files. We'll default that one to the same as the default one there as well. Okay, so we've set up the private variables and the child object. And we need this one to inherit from gradient sky common. And then now we actually need to create a child object. So we don't want to assign the mesh onto the camera itself. So I'm going to do so that it creates a child object instead. So we'll create a method for that. Create a child object. And in fact, if we already created one, we need to check first if there is a child object of the camera. And since this component is going to be on the camera itself, we know that the transform is of the camera. So we can do a transform find, and let's call the camera fixed gradient sky. So the child object will be called that. And this is looking for that object. And if that child doesn't exist, or if it's not nothing, then we will do assign it actually. So if it finds it, so if it's not equals nil, then we will assign that transform to be the child object. But we'll actually use the game object component of it. So and then we want the actual game object of that one. So if it exists, we want to just say that, okay, the child object is going to be referenced by this child object variable. If it doesn't exist, then we want to create it. So create a new game object and let's give it that name. The name is important since we're using that to find. It could be anything as long as it's the same everywhere. And then we want to move it so that this actually becomes a child object of the camera. We want to access the transform component and then change the parent of that one to be this transform, which is we're working with the camera. This script's going to be assigned to the camera. And then we want to reset the rotation, so ensure that the local rotation is the same as the camera's. So we set the local rotation to quaternion identity, which is a default, or the same as the parent then. And then we need to position this game object in the right place. And that is reliant on the place at clipping plane that we created before. So if that one is the near clipping plane, then we want to position this child object So the transform component of it, we want to put the local position of that one to be a new vector 3. And x and y should be 0. And the z variable should be the distance that we want it to be away from the camera. And we can access this by the near clipping plane variable of the camera component. But we can't put it right at the clipping plane. We need to have a slight to ensure that it's actually within or beyond the clipping plane. So if I go here, this is the clipping plane, the near one. We can't have it exactly on it, so let's place it right just in front of it here so that it's actually visible. Okay, local position it should be. And then if it's not near, then it's going to be far. So we want to place it at the far clipping plane, but instead of adding 0.1, we want to deduct 0.01 to ensure that if it's all the way over here by this far one here. So this distance one here, all the way over here, we want it to be sure that it's not beyond that one. We need to be still so it doesn't clip it away. And since we're only using one line of code, we don't really need these squiggly brackets either. So trim the code a bit. Yeah, and then we want to ensure that this object has the mesh filter and mesh renderer. So we add the component mesh filter. And a mesh renderer. And then if you remember, we created this method, which we've moved to the common now, called create mesh renderer. And we want to create a mesh renderer for this one as well, and disable all the flags like we did on the old one, or on the other one. This one, however, creates it for whatever script or for whatever game object this is assigned to. So we need to modify it slightly. So if we do create mesh renderer, let's pass along, what should we pass? Let's pass along this transform so we know which object it is. This goes red because this is not expecting any arguments, but we can add that. And then we default that one to null, so the other one works, the one that we've got in this one. So we default it to nil, so the object will, this gradient sky object will still work because it's gonna not pass any argument, and then it's gonna assign it to its own. But we do need to check if target is null, then we'll assign target to be the local transform. And then we do targets get component. So now with the change that we made here was that for the gradient sky object, it'll be the same. It'll create and get the component of itself, because if it was nil, it'll use its own transform. But for this camera one, we want it to be passed to the child object. So when we create the mesh render, we want that to be assigned to the child object. So we pass that one along and use that one instead. And then let's update the cache clipping plane to be where we placed it. And then let's assign the actual mesh as well, or create the mesh and assign it to the child object. So child object. So we need to assign it to the mesh filter component, and it's the shared mesh that we want to assign. And then let's create the mesh. There we go. So now we've got a method to create this child object, or get it actually, because if it's already existing, then it's assigning it here. So let's rename this one to make sense. So create or get child object, because that's what it's doing. by itself, it won't do anything now because this is just a method to create a child object. So now we need to actually handle it when you add the component. So I think we need to have a method as well to destroy it if a duplicate exists. So let's create a method for that to destroy it if it exists. So basically we just look for it if it finds as a child. So if it's not nil, that means that it exists, and then we can destroy it. And since we're working in the editor as well, execute in edit mode will do destroy immediate, so it's not causing any problems in the editor. Let's copy this instead. And it's the game object we want to destroy. So whenever this component is enabled or disabled now, so in mono behavior, you've got a method called onDisable. That's if the game object is disabled. Then we want to destroy the child object so that this sky disappears. So we call that method that we just created. And when we enable it, so another default method in the mono behavior called onEnable. So when the game object is enabled, we want to call our method to create or get the child object. So, okay, and then we need to do what we did with the other one as well, which is the reset method. So remember, this one is called whenever a component is added, or if you click this reset button on in the inspector here. So those are the only time this reset one is called. And if with this one, first we want to check that that this component is actually assigned to a camera. So if we check the component camera, if that one equals nil, then we want to throw an error. So we want to just abort and say you need a camera. So we'll return from this one. So it won't do anything. It won't create any child object or anything like that. And then what we want to do when we've ensured that there is a camera, we want to create a child object. Or first we should create the gradient actually. And when we press the reset, we want to do a hard ensure that, or sort of a hard reset to ensure that the child object is recreated. So let's also destroy it for that sake. So we'll create the default gradient. We'll destroy if there's another object there for some reason, and we'll ensure that a new one is created for it at the reset. So this is only executed when a component is added the first time or when the reset button is clicked. Okay, so let's see if we get any compile errors here first of all. We can delete this gradient sky now. We're going to be using a different one, and let's try to add that component. So far so good, but we've got some errors here. So we got an error here saying that there's a null reference exception, and that's probably because either the child object or the camera is not assigned yet. It can't be the child object because we've actually created it here, so it must be the camera. And that's because we're not assigning that one anywhere yet. So what we could do is we'll do this one public to ensure that it's serialized. Rename it to ensure that we can identify it as a public. Okay, it's conflicting with the default word, so let's just do camera ref then. And let's do a hide in inspector, because this one we don't want to see either, or we don't want the user to be able to mess around with that one. but we want it to be serialized, so that's the only reason why I'm making it public. And let's assign it here. So we're setting the camera component here. First we ensure that there is a camera component, and then we get it here. So now hopefully this should not throw that error again. Okay, we still get an error, and it's in the same place. So we got line 28 first of all here. So on enable, create or get child object. And then we go here, create or get child object. Maybe it's because it still had, let's ensure we do this from scratch actually. Okay, we still get the error. It does create the object. So the child object is created. It's assigned. The parent is assigned, so that's all good. We do a check of the local, or we set the local position to be camera ref near clipping plane. So, okay, I see now. The reason why this is happening is because on enable is executing before reset is called. Since the object is both enabled and the reset method is called, with the multi-threading, this one is actually executing before the reset one does. So we should move this one. Let's move it into here actually. But that's not pretty either, because we don't really want create or get child object method to assign a camera. So that's probably not good practice. Let's do it in the unenable maybe. There we go. Let's check actually if what the order is for that. Order of events. So let's have a look. We do, well, this one says that reset should be called before on enable. So it's a bit surprising that we're hitting that error, since we did put the assignment in the reset one. So maybe that's something to keep in mind. For now, let's just put it in both places to ensure that it's set by the time it gets there. And now that works. We don't get an error, but we do have a warning because we're not using this one yet, the cache, which is fine. We haven't gotten to that point yet. Basically now when we change anything, nothing's going to change on the screen because we haven't done the update function to look for any changes yet. But as you can see now, if I go to the camera, it's created this mesh right at the near clipping plane. So it's visible in the screen. And it's not correctly sized at the moment, so that's probably the next thing we're going to do now to ensure that it resizes itself to be exactly the size to cover the viewport here. So let's do that next. So we create another method called set mesh local scale. And we want to do a float. First we need to calculate the frustum height. Frustum, I can never pronounce that word. Frustum height. So the viewport height and the camera viewport height. What's visible? Let's spell it correctly as well. frustum height. And this one is actually available at the Unity documentation, how to calculate this. So we get the child object transforms position and Z, because we know that this is the distance. We need the distance from the clipping plane here, or of the clipping plane rather, plus the 0.1 that we created, because we need the position of the mesh in relation to the camera. And then we want to do it with a tangent of field of view times 0.5 multiplied by degrees to radians. So the actual formula for calculating the height of the viewport or the frustum is, you can find that in Unity's documentation if you need to. The only difference I made is that I assigned it the Z position of the mesh, local mesh, because I know what position it is from the camera. So that's the only parameter that would be different from what is in the Unity documentation. And then we need to set the local scale now. So now that we've got the height, let's set the local scale to a new vector 3. And we do the height. And we need to multiply this by the camera's aspect ratio. And the aspect ratio is basically the relation between the width and the height of the camera, whatever it's displaying at the moment. So that's the width, the X value, and then the height is the height multiplied by camera aspect divided by camera aspect. And then for the Z value, we don't need to care about that one. But let's set it to 1 actually, for good practice. It doesn't really matter whatever scale it is since it's a flat mesh, but 1 is better. And let's update the cache that we created, because now that we've set the scale, we need to set the cache of the, first we'll do the field of view. And then let's update the height and the width. And for this one, we'll actually use the pixel. These are integers, so the viewport pixel height we want. And then we'll do the width as well. So there we go. This is a method now that calculates what proportions it is for the viewport and then sets the local scale of the sky mesh to fill this exactly. And it also remembers this in the cache, so we don't have to check the actual variables later on. We want to just check the cache if it's changed. So if we start this, we're actually not calling this method, so that's the next thing we should do, and we should do this in the update function here. Here we need to copy a few things from the other one as well, because we want to still do the same changes, same checks. If you remember, we checked if the color keys array had, if you had added or removed any color keys here. And if there's one more value in the array, then this should trigger and it should recreate the mesh. And the same thing for the number of color keys. When you if the number of the color keys are the same, but any of the color values have changed. So if you've modified anything here, we also need to detect that one, and that's what this one does. And that was in the previous video. If you didn't see that one, you can have a look at that part being coded. So we get an error here, and that's because the mesh filter exists not on this game object, it's the child game object. We call that one child object. Let's see, now we need to actually get that component because we don't have one, so we'll get the mesh filter component and set the shared mesh of that one. And it's not a problem getting the component here, even though we're in the update function or in the update method. And get component is a bit of a performance thing to be wary of, to not do it too often, but we only execute this line of code if a key has been added or removed. And same down here if a color value has changed, so we can actually use that one okay in here. So now we should have recreation if we do change anything here. Yeah, we can see that the mesh is recreated as we change these values, so that's good. But it's not resizing yet. It's still the wrong size, so that's the next thing we should do. And the same as we did with the gradient, we can check here. So if the absolute value of the camera field of view, we'll start with that one, minus the cached field of view, if that's greater than 0.01, then we should recreate the mesh again and return. And again, we're returning straight after we create the mesh, because if we recreated the mesh, it doesn't really matter if anything else has changed. We don't want to recreate the mesh multiple times. So if the field of view has changed, it's going to recreate the mesh. So no need to continue in this update method. So let's see if actually we should not recreate the mesh. What we should do is set the mesh scale that it should call this method that we created, because we don't really recreate it. We can just set the local mesh scale instead. So now if I change the field, as you can see now, it detected that the cache version value and the camera's actual field of view value were different. So it went ahead and called this set mesh local scale method. And then it resized it to fit perfectly in the size of the viewport here. And if I change the field of view here, it should resize the mesh appropriately. If we didn't have this line of code now, and I resize, nothing happens. So that's just checking the field of view. There's a few other things we need to check for, and that is the size of the viewport, so the aspect ratio. So we want to ensure that it updates if that's changed as well. So instead of just checking the field of view, we want to add here that if camera ref pixel width is not equal to cache camera width, or if the height is different. Then we want to do the mesh change. And the reason why we can do equals rather than approximate here, which was the workaround we had to do with the colors, is because these are integer values, so they will always be the same. They're not approximate, the integers are always exact. And there we go. Now it's detected that to the viewport. So now when I change this viewport, it'll resize this one as well. Final thing I think we need to check for is also to ensure that we haven't changed the clipping plane. So that's one more thing we need to do here. So if place at clipping plane doesn't equal the cache clipping plane, then we want to destroy the child object if it exists, and then this is the simplest way probably to do it, and then just recreate it. Because then in this create or get child object, since it's changed, it'll come to this line here and detect that, okay, the clipping plane has changed from one to the other, and it'll place it at the new location. Okay, and it's not resizing, so we need to fix that because it's actually recreating it after it was resized. Which is a bit interesting since we're actually, oh yeah, in the create, let's set the scale correctly at the end of this as well, create or get child object. Let's call this set scale to ensure that after it's recreated, it's set to the correct scale. There we go. So now if I change from far, as you can see, it places it, to zoom out, at the far distance here. Let's change the field of view down to 60 again. And now we have a one, so if I rotate this camera now, this one will always stay static. So if that's something you need, then you can use this version of the script instead to ensure that whatever the camera does, the sky should always be the same. Usually you wouldn't want to have it for rotations anyway, but in a platformer, for example, where all you do is move side to side, and then you want to maybe scroll, let's see here. Let's move the camera closer again. So here, for example, if you want to do some jumping here, then the sky stays the same. And you could have other parallax effect, for example, but maybe you want the sky to always be static, so this one is probably better to use then. And again, if I change, or actually, let's see now, if I change this to near, you see that the level disappears, and that's because we're actually rendering this over, it's rendering this right in front of the camera, so it'll block everything behind it. So we need to fix that. And we can do that by editing the shader that we had before. And in here, we want to change the Q. So we create a tag, Q. We want to place it at geometry. Geometry is, this is basically an integer number. That's a sorting order. So if I do geometry, which is what this is rendered at, which is 2000, as you can see here, render Q. When I change it to -1000 maybe, to ensure that it's rendered after the geometry. So render Q 1000. And another thing that it's doing, it's actually writing the Z value, so it's occluding everything behind it. So we need to also disable that one. Z writes off, and now it appears. So basically what we did in the shader now was to tell it that the sky should always render last. So even if it's placed in front, it'll draw this one first, prior to the any geometry. So it'll render this, place it in the screen, and then it'll render everything after that one. And we also disabled the Z write so that it doesn't believe that anything is included behind it. It's just not writing the Z value here. So now it doesn't really matter where we place these objects. As long as they're in front of the camera, they will always be visible. Okay, finally, I think if we disable this now, as you can see, it destroyed the game object, and if I enable it again, it'll recreate that game object. And if you don't want this one to be visible in the hierarchy, maybe just happy with having the component here and nothing else, then we can actually disable that one as well. So in the camera here, when we're creating the mesh or the child object here, let's hide it. Hide in hierarchy. So now when it's created, you don't see the child object. And another nice thing with this one is you can't accidentally select the background all the time if you're editing your level. As with a separate object, you'd constantly be maybe clicking the background and accidentally selecting it. And this way, we've got the background and you don't risk selecting it, and it's quite easy to just change. The thing is now you can't get that parallax effect, and if you want movement of the background, then you're better off using this second one. So if we disable this one, we create an empty game object and called game object gradient sky, and then we assign the other component to that one. This is the one that acts more like a traditional one that you can just place where you want it and scale as needed. Okay, so I think we're finished now. We've got the two versions of the gradient sky, one that's acting as a game object, and the other one is as a fixed camera component. And what I'll do now is I'll document the code and tidy it up a bit, and I'll make it available in the asset store, so you can download it there as well and use it in your games. And then if you like this, please subscribe and press the like button if you can. And also be sure to check out my website, www.infencia.com, for all the stuff that I make. I do game assets and games and sound and music and stuff like that. So please check that out if you get a chance. And thanks a lot for your time, and enjoy coding in Unity and enjoy the gradient skies. Thanks a lot, guys. Bye.